Good morning, and thank you for joining this monthly media briefing, part of the suite of services that NOAA provides to government, business, academia, the media, and the public to support informed decision making. I'm John Bateman with NOAA Communications, and I'll be facilitating today's briefing. Today's update will feature two short presentations from NOAA NCEI and NOAA CPC. After the presentations, our NOAA experts will be available for questions from the media, which can be asked in the Q&A box located at the bottom of your screen. Also, the slides from the presentation will be available for download. Just click the link in the download window also at the bottom of the screen. And with that, I will introduce our speakers. The first presenter is Vose, the Chief of the Monitoring and Assessment Branch at NOAA's National Centers for Environmental Information, or NCEI, who will provide a summary of the January 2025 U.S. and global temperature and precipitation analysis, as well as the latest drought monitor update. Our second presenter is Anthony Artusa, a meteorologist with NOAA's Climate Prediction Center, or CPC, who will provide the latest El Nino-La Nina update, as well as the U.S. seasonal outlooks for temperature, precipitation, and drought for the next 3 months. We will kick off this media briefing now with Russ from NOAA NCEI. Russ?
Thanks, John, and good morning, all. I'm going to start here this morning by talking about the things at the global scale. January 2025, the map here shows you what things look like. If you see something in red, that was above normal temperatures. If you see something blue, those areas were below normal. The punchline is that the surface temperature was 2.41 degrees Fahrenheit above the 20th century average. So that was quite a bit above normal. The last five of the 5 warmest years on record for January have all happened in the past decade, and this was among them. The warmth at the global scale was notable because it occurred during a La Nina episode. And if you look at the map, you see colder than normal temperatures in the eastern tropical Pacific Ocean and along the coast of South America. That tends to tug down global temperatures, so it's a bit unusual that we saw such a warm January when that was going on. The features geographically, I'd point out otherwise. It was much above average over the Arctic and Alaska and Canada and Central Eurasia. We had anomalies in the orders of 4 to 5 degrees or maybe even 6 degrees Celsius. That's much above average. But it was below average in the lower 48 states, in much of Greenland, and a few other areas like far eastern Russia. One other statistic that's worth noting is we do track not just surface temperature, and this map depicts surface temperature departures for January, but we also track temperatures in the upper atmosphere. And the mid-troposphere, roughly 2 to 6 miles above the surface, was also well above normal, 0.9 degrees Fahrenheit above the 1981 to 2010 average. I think that was the 3rd warmest on record. Now moving on to what we might call significant anomalies and events from January. This map highlights a few of the key things to consider. And I won't draw your attention to all of these, but I want to point out a few. One of which is global precipitation. This seems like a strange headline, but last month, global precipitation was very near average for the globe as a whole. That's worth pointing out because that's not always the case. Back in January of 2023, it was the 2nd lowest global precipitation on record. But this month, or last month, was relatively normal. There were 5 tropical cyclones across the globe. That's 2 below the long-term average. And 3 of them were in the Indian Ocean, including one that did considerable damage to Mozambique and Madagascar. Snow cover for January, what was really notable was Eurasia. That was far below average by 940,000 square miles. I think that was the 2nd lowest Eurasian snow cover we've seen in our record, which goes back to the 1960s. And sea ice, Arctic sea ice, was also far below average by about 1.17 million square miles. That was also 2nd lowest on record for the Arctic. And again, that's for January. Now moving to the US, we have 2 maps here. The map on the left is temperature. The map on the right is for precipitation. We'll start with temperature on the left. Again, if you see something in blue, those areas were below normal for the month of January. Anything that's reddish was above normal. And the obvious message here is you see a lot more blue and grayish than you do red. And consistent with that, it's worth pointing out that January 2025 was actually the coldest January since 1988 in the lower 48 states. Much of the southeastern part of the country and the mid-Atlantic, or parts of the upper Midwest, I should say, were below average, as were parts of the West, say New Mexico, Colorado, and so on. Above normal areas were confined pretty much to the West Coast and the upper Great Plains and part of the great state of Maine. But it was a cold January in the lower 48. The map on the right shows you precipitation. This is percent of average, if you will. You see something in brown, it was drier than normal. If it's green, it's wetter than normal. And the punchline here, obviously, is that most of the lower 48 was below normal or well below normal. I think the area average for the lower 48 was 1.39 inches. That's almost an inch below average. I think this was the 6th driest January on record. In fact, the only areas that were really above normal are parts of Montana, Wyoming, eastern Colorado, Kansas, and some parts of eastern Texas and Arkansas and Florida. Not much. Most of the rest of the country was pretty well below average or near average, particularly the Southwest. Pointing out a few significant anomalies and events for the month of January. I'll start up in Alaska, which doesn't always get as much press, but it was actually the wettest January on record for Alaska, and there were some record high temperatures in a few places. The Southeast had some snow and some very cold weather because there was an Arctic air mass that showed up there toward late of the month. I think started roughly January 19th. And a wide swath of the country there got anywhere between 6 and 12 inches of snow, particularly coastal regions of Texas, Louisiana, Mississippi, Alabama, and the Florida Panhandle. Then, of course, the other big story for January was the wildfires in Southern California, including the Palisades and the Eaton fires, which consumed more than 49,000 acres and destroyed over 16,000 structures. It was driven, of course, by the dry conditions and the high wind speeds associated with Santa Ana winds. And last but not least, the current picture for drought. This is the map as of February 18th, meaning just 2 days ago. It's the most current map we have. If you see anything that's in color here, meaning yellows and reds and browns, those areas are currently experiencing drought. Overall, 57% of the nation is abnormally dry or in drought. 67% of the lower 48. 15% of the nation is in severe drought or worse, and approximately 126.5 million people currently live in an area that's experiencing a drought. All of these statistics are slight increases from about this time last month, and the droughts are particularly focused in the southwestern United States. Basically all of Arizona and Utah, for example, are drier than normal. Much of southern California and southern Utah, western New Mexico, southern and western Texas, and then of the upper plains, such as Wyoming, South Dakota, Nebraska, Minnesota, Iowa, and so on. So, and along with parts of the Atlantic coast are drier than normal. So a lot of drought right now, a bit more than half the nation, and we'll continue to track that. Now I'll hand the mic off to Anthony.
All right, thank you very much, Russ. So I'll continue on then with a look at the sea surface temperatures and what is called ENSO, or the El Nino Southern Oscillation. We're now on slide 7. And here we're looking at a picture of the Pacific, or a map of the Pacific. Notice on the east side, just for your bearings, we have Central America, South America, and then at lower left, we have Australia. So just to get your bearings a bit, you can see that where you have the blue shading, that is representative of colder than normal sea surface temperatures. And where you have the orange shading, that's where we have warmer than normal sea surface temperatures. This is a La Nina that's going on right now, and the pattern that we see here does feature the below normal sea surface temperatures across the central and the east central Pacific. Okay, moving on to the outlooks. The first for March, we have the monthly temperature outlook on the left-hand side and the monthly precipitation on the right-hand side. And normally when we make these types of forecasts, including the seasonal, which is to come, we tend to use a number of climate models, which are both dynamical and statistical in nature. We also look at composites of past El Nino or La Nina events and a number of other tools. So in this case, you can see that for the temperatures on the left, we're going with below normal temperatures being favored across the Northwest. And we also have above normal temperatures being favored across much of the southern tier and across the Gulf Coast states. For Alaska, the below normal temperatures are favored over the southeast and south central portions of the state. And we have some above normal temperatures favored over much of northern Alaska. Moving on to the precipitation on the right-hand side, in this case, we have above normal precipitation expected across the Northwest, the Northern Rockies, perhaps even down into northern parts of California. We also have a large swath of above that you see indicated from the Great Lakes southward down, approaching the lower Mississippi Valley, and a broad area of below normal precipitation chances across the Southwest and parts of the South Central states. Notice for Alaska, although the tilts toward above normal are fairly weak, there is that tendency for above in the northern, let's say, 2/3 of the mainland. And then we have equal chances across the southern third of the state. And the equal chances simply means that the chances for above, near, and below normal are equal or very close to being equal. And therefore, we don't have enough information in our guidance to tilt the forecast toward either above, near, or below. Okay, so I'll move on to the next slide. We should be on number 9. And this is the seasonal forecast for March, April, and May. You'll see a lot of similarity with the monthly forecast, primarily because of our ongoing La Nina, which is expected to have an impact at least for the first half or so of the season. We're going with below normal temperatures again on the left-hand side, favored across the Northwest, and above normal across much of the South and eastern portions of the lower 48 states. Historical trends are also fairly strong at this time of the year for the warmth in the east, but they do get stronger as we move into the summer. And for Alaska, we have below normal again over the southeast part of the state and above over the northern and western part of Alaska. Moving on to the precipitation, above normal precipitation is shown there in green across the Northwest once again. Also from the Great Lakes down to the lower Mississippi Valley. And these are very consistent with La Nina composites, or what often is observed during La Nina winters. Also below normal precipitation across a large chunk of the Southwest, the central and southern plains, and even a weak tilt toward below for Florida. In Alaska, we have very weak tilts toward below, right along the southern coastline, and a weak tilt toward above in the northwest part of the state. So I will go on to slide 10, the drought outlook. And this was just issued this morning, and it's valid through the end of May. So where you see the brown shading, you can see the legend or the key at lower right. This indicates that the drought is expected to persist. I should mention that this is based heavily on the U.S. Drought Monitor that Russ was showing earlier. Let's say the yellow shading represents where drought development is likely. Then we have the tan shading, which is where drought remains but improves. As an example, it would be like, say, D3 to D2. That would represent an improvement in the drought. And then the olive covered or olive shaded green represents drought removal is likely. So you can see that for most of the, or should say for much of the lower 48, where there is currently drought, It looks like a lot of it is expected to persist. We do expect some areas of drought development that are likely in the areas in yellow. And then for the areas where we expect some improvement or removal, those are in places like the Pacific Northwest, the Great Lakes area, parts of the Tennessee Valley, and also up in New England. For Alaska, we also have some drought development possible there along the southern coast, and this is in regards mostly to uh, unusually low snowpack in the higher elevations. Okay, so that is what I had, and I will turn it back over to John.
All right, thanks so much, Russ and Anthony. We will now open the briefing to questions from the media. As a reminder, to ask a question, please find the Q&A box located at the bottom of your screen. Please type in your name, affiliation, your question, and the specific expert you would like to answer it. And we have one in here right now. We don't have a name or affiliation with it, but Russ, this looks like it's for you, and this could be a good one. Why was the US so much cooler than the rest of the world in January?
Thanks, John. There are a couple of factors, but the primary driver was the fact that there was a ridge of high pressure sort of over the Pacific and West Coast, and then another blocking feature over Greenland. And what that helped do was helped cold air basically spill in from the Arctic and just settle in over the US over a good bit of the month. And so we had a cold January.
All right, thank you. The next one is from James Deneen from the New Scientist. This could be perhaps either for you, Russ, or Anthony. You mentioned the notably warm global average temperatures despite a La Nina episode. What are the main factors driving those high temperatures?
So I'll go ahead and take this, Anthony, and feel free to chime in. We don't tend, James, we don't tend to like put out an explanation for why a specific month was warmer or colder than normal at the global scale. That's actually very hard to do unless something dramatic happened, like, I don't know, a volcanic eruption or something like that. But we can sort of comment longer term. And, the warmth that we saw, like, say, last year, for example, is probably tied to, and in more recent years, have probably been tied to things like, reductions in air pollution over the ocean, particularly the North Atlantic and North Pacific. The shipping regulations implemented in 2020 reduced the emission of sulfur dioxide, which tends to encourage low-level cloud formation. You have fewer emissions, that means you have fewer clouds and a little more sunlight reaching the ocean and warming it. Or along the same lines, there's been a longer-term decrease in cloud cover, or at least there's a bunch of evidence to suggest that. There was a recent study by NASA, for example, that found a small but tangible drop in global cloud cover over the past 2 decades in the tropics and the mid-latitudes. So it's those sort of those longer term things that might account for why the recent years have been a little bit warmer. But I don't have a specific explanation for why January 2025 was particularly warm, but I suspect those factors contribute.
Great. Thank you so much, Russ. The next question, Davis Nolan, WKRN Nashville. This might be for Anthony. With La Nina to neutral forecast for above normal temperatures, precipitation for our part of the country for March, April, May, can you comment on if this will have an impact on the spring severe weather season for the mid-south of the U.S.? So it looks like he's looking for around the Nashville, Kentucky, Tennessee area. Is that an indicator for their severe weather season?
Hi, this is Anthony. This is a challenging question for sure. Normally, what we would look at when we consider severe weather during the springtime in the Mid-South is the amount of wind shear that is normally available. Um, and also, I know there have been specific studies that have been done. I just can't point to one offhand. But I think I'm not really sure how to if we can say really that much, except in very general terms, on the severe weather season. There are a lot of different factors involved. There's a lot of variability within the season. And the only thing that comes to mind right off the bat is the amount of wind shear. But I'm afraid I really couldn't answer it beyond that.
Okay, thank you, Anthony. Next question from Brian Sullivan from Bloomberg. He said, hi, I missed the last point about the snowpack being below normal. Could you repeat that? And where was that and what caused it?
Hi, this is Russ again, Brian. I think I spoke about snowpack a little bit. I think Anthony did. When I was speaking, I was talking about a snowpack over Eurasia. That was much below normal. It was actually the second lowest snowpack over Eurasia on record for the month of January. I hope that answers your question.
Thank you. And I'm not sure who would be best for this, but Craig Miller asked about the polar vortexes or vortices this winter versus a typical 2 to 3 that we might see. Is the fact that we've seen upwards to 10 be an artifact of La Nina or something else?
This is Russ, Craig. I'm not sure I can shed much light on this. I think there's been some work to suggest that going forward, there may be more wobbliness in the polar vortex, which might lead to more outbreaks of cold Arctic air as we go forward in time. But there's a lot of variability associated with that, so I'm not sure it's a really strong signal.
Okay. Thank you so much, Russ. I'm not seeing any more on-topic questions from the media, so just as a reminder, please type them into the Q&A box at the bottom of your screen. And I believe I'm not seeing any more. So with that, we can put up our last slide for more information. Thank you. And I will wrap up this briefing. First, I would like to thank everyone for their time and for everyone for participating in this briefing. I will end by reminding you to mark your calendar for a few upcoming events, and I'll read them slowly so you can mark them down. The release of the February 2025 U.S. temperature and precipitation analysis is scheduled for March 10th at 11 a.m. Eastern Time. The release for the February 2025 global temperature analysis is scheduled for March 12th at 11 a.m. Eastern Time. And we have something coming up in March. In lieu of our monthly briefing in March, NOAA will host its 2025 U.S. Spring Outlook media briefing at 11 a.m. Eastern Time on March 20th, coincidentally the first day of astronomical spring. A media advisory for that will be issued and posted online ahead of the event. Thank you for joining this monthly briefing and have a good day.